Okay. Hey there, everybody, and welcome to our first official topic study group. Today's
Quick
topic
question.
one, getting started with
Sorry.
data science.
I just realized you asked for questions.
Oh,
I can't
yeah.
download the notebook. It won't let me on Slack since we're on the Slack topic.
Oh,
It
perfect. I'll talk about that. I will talk
doesn't give
about
me
that.
one to download at all when I click the download button. So that's my question.
Okay,
Sorry.
yeah, I'll talk through that as well. So let me just make a note to remember to say that. Okay, awesome. So yes, first study group. I want to talk about some like Slack workflow things, and then we'll get into the notebook that I sent out. Not super important to like follow along. I know for a lot of people, it's hard to like multitask working on their notebook and watching me do it. So all of these recordings will be posted on YouTube. And I usually post them within the first couple of hours after. So, all right. So what we see here is our Slack channel. I wanted to point some things out. Every Monday or Tuesday, if Monday is a public holiday, we do have a few off Mondays coming up. Every Monday, I'm going to be posting a stand-up. Very, very important that you add your stand-up. I think this kind of Scrum process, if anyone's interested, feel free to look up Scrum. It's a process that a lot of tech companies use and a lot of teams use to just, keep each other accountable and, just it's easy to like just write out what it is that you're working on. So you have like a checklist of things. So how this works is I'm going to post one every Monday. If you're online on Monday and you don't see my post yet, feel free to throw your own there to start us off. But in a thread, and for any message, if you click reply in thread, it's going to create a thread like this. And then you'll be able to leave your stand-up. Got some questions about how to like do multi-line. So you do multi-line. Let's say I type my yesterday, whatever. You hold down shift and press enter to do the second line. And then you can just keep doing that. So that's on stand-ups. I will be calling you out if I don't see your stand-up for the week. So if you don't want to be shamed by an @ on Slack, do that. Okay, so other things with Slack. Not all of you need to do this, but you can actually edit your Slack profile. So if you edit your profile, you can change your like full name and some of your display names. I know there's actually like an automatic display name, so just double check. I would like your name to be something that I can identify you with. That would be great. A photo would be nice so that I can, see your face, but not a big deal either. Other things, you can now put your pronouns in Slack. That's pretty cool. And special request for those of you named John or Justin, because we have multiple Johns and Justins. If you could just throw your last name onto your Slack name, either the display name or the full name, that'd be really helpful for me. But yeah, special note for Johns and Justins. Okay. Regarding downloading files on Slack, I will say that I'm not usually going to do this. I'm actually tomorrow going to talk through a GitHub workflow of getting my study group notes. But for today, you should be able to download this. And once you've downloaded this, the downside is, I think my
that's the problem I'm hitting. It's doing the exact same thing it's doing to you.
Oh, okay. If this is not working, then no worries, because tomorrow I will be, actually, I'll point you all to another place where you can get this in a little bit. But usually if you just click download and then you would have to like CD in your computer to open it up. If that's not working, that is super weird. I will give you an alternative right now. But before that, any other Slack questions? Cool. Oh, another Slack workflow that I want to mention. You might see yourself. So I have a lot of channels and like DM students because I have a lot of students in a lot of classes. But ways that you can make use of Slack is you might find yourself. If you see yourself in the column, this is actually a really great space for you to put in notes. I like to keep a lot of my notes here to myself. And this is actually something that I meant to send in your channel. So feel free to use your own DM space to, jot down notes for yourself. If you want to take down questions for me during one-on-ones, that's a way that a lot of students use this. So on Slack, there is your own section. There are also a bunch of channels. I actually am just about to post this in our channel here. there are a lot of student-driven affinity Slack channels. And those are basically community channels that are they're student-led. And once in a while, a staff member or community member will like post discussion questions or like even like job opportunities, just fun networking opportunities. So if you identify with any of these, to join them, you just click on it and it brings you to the channel and lets you join them. So it's a fun place to just like, you know, meet other folks from Flatiron. Cool. Any other Slack questions before I show y'all where else you can get the notebook that I'm using today? All right. Oh no, it looks like Justin can't seem to join Zoom right now. Good thing we're here. Does this include? All right. Okay, I'm going to switch my share screen now to show us where else we can get this notebook. So this notebook lives locally. However, on your homeroom page, I've actually put a link to a study group repo. Don't worry about this so much for now, because I'm going to go through how we're going to use this tomorrow during our GitHub section. But if you click into here and click into phase 1, you'll actually see the exact same notebook. So if you have trouble downloading the notebook off of Slack for today, and you really want to, you know, see this code, I will say today's one is going to be basic. So if you feel pretty comfortable with Python, maybe you don't have to. But if you just want to get this really quickly, click the download code button, click this and git clone this repo. So you can pretty much do this step here. And instead of this URL, just use this URL. If this still doesn't make sense, I'm going to go through this in detail tomorrow. But this is just for people who are having difficulty downloading the notebook. All right. Anything else before we get into material? All right. Okay, so let's get started. A lot of the stuff here are basics. I will say that because of pre-work, and actually for some context, pre-work was only introduced, I think, a couple months ago. So thanks to pre-work, a lot of you have seen a lot of these basics. I do want to go through them like fairly quickly, and there are a couple little parts of Python that I want to highlight because those will be very, very useful in the upcoming topics. So we're going to do that real quick. Hopefully by now or by the end of today, and if you're keeping up with the day-to-day topics, you have set up your environment. If anyone has environment setup issues, please let me know. I know that there might be a couple people working on Linux systems that have a slightly different installation process. So if anyone has issues there, let me know. But these are some terms that you might have come across that I guess seem kind of foreign. So the first thing you have to download was Anaconda. Anaconda is basically a package management software. So in the future, when you're using different Python packages, you'll be able to download them and manage them through Anaconda. Git is something that we'll go into much more detail tomorrow, but Git is a version control system for tracking your changes and coordinating your code. For our purposes, I'm going to have you all work closely with Git when you're working on your projects. So in another couple of weeks, we'll really get familiar with how we work with Git. Next, we're going to talk about the differences between notebooks and Python files. So within Jupyter Notebooks, we are coding in Python, but there's a slight difference between a Jupyter Notebook file, which ends in the IPYNB. So this file extension IPYNB is a Python notebook file, stands for Interactive Python Notebook. And there are also Python files. So Python files, they are more for scripting, which is something that we'll get into later. And finally, the last thing you have to set up was a learn environment. So if you remember that like Conda, Activate, Learn, Env, what that stuff was all about, what is a virtual environment? Oh, and by the way, I see the question in the chat. I will get to that in a little bit. What a virtual environment is, for our purposes, this virtual environment has basically downloaded all the versions of packages that our program uses. So what this is used for in other scenarios, let's say you're working on this large scale app and you're creating it this year in 2021. And you're using all the packages that are available to us in 2021. And let's say you build your thing, you build your project, you leave it aside, and 3 years down the road, you just want to take a look at it and run it again. Maybe 3 years down the road, Python 4 comes out, which comes with a slew of changes. A lot of your code might not work the way it's supposed to work. This was a big problem when Python actually upgraded from Python 2 to Python 3. There are actually some jobs out there whose like sole purpose is to translate code from like Python 2 to Python 3 because a lot of the syntax changed. So what a virtual environment does is it allows you to have sort of like a list of packages and their specific versions that match the versions at the time you were creating this project. So that's what a virtual environment does. And for our purposes, we just download all the specific packages that work for our program, just so that you don't have any like weird dependencies errors that might pop up. But in real life, that's more so what virtual environments are used for, to just make sure you have the right versions of packages that you're able to reproduce and rerun your code years in the future. All right, so let's take a look at the question. Is it possible to use a desktop and a laptop for this? Host forks on 2 computers, one for home and one for being mobile? Absolutely. We can talk about this more tomorrow. But let's say you have multiple computers. I actually have 2 computers as well. I have my work computer, which is this one, and I have my personal computer, but sometimes I only want to carry one laptop with me. If you're using GitHub, and I'll talk about more of how you can do that with your labs tomorrow, you can definitely take advantage of Git to sort of like save your work into the cloud so that you can access it from different computers. As long as you make sure that you're, pushing your changes back up to the cloud, you can definitely work across multiple machines. And I'll talk about what that looks like tomorrow. All right, one more thing before we get into like Python, I want to introduce notebook extensions. So if you take a look at my notebook here, we have these like little, what do you call these? Collapsible headers, yeah. So we have collapsible headers here, and this is a functionality of notebook extensions. I like this, especially for when I'm, doing these study groups. I don't like to have like a long scroll of notebooks. Something else that's really neat here is I have like a table of contents here. If you want to get this functionality, these are called notebook extensions, and I have linked, where did I link it? Here. I've linked an article walking through how to get this on your computer. One unfortunate downside is that these notebook extensions will only be for your local Jupyter notebook, not the case for Illumidesk. Unfortunately, we can't add extensions to Illumidesk. But yeah, if you ever wanted to get like these collapsible headings, which I personally like a lot, yeah. All right, I see another question. What version of Python will we be using? Any versions between 3.6 and 3.9 should be fine. If you do the learn environment, I believe it's 3.6. My Python is actually on 3.8. Between these versions, there haven't been like drastic changes. So as long as you have a Python version between like 3.6 and 3.9, that should be good. I think 3.9 like recently came out in maybe the last year. I don't remember. My concept of time is all not right now. But yeah, as long as it's Python 3, most importantly, just because Python 2 has some pretty big syntax changes, you should be fine. As a quick example of a syntax change, actually, I actually started learning Python when it was Python 2. In Python 3, when we print something, we do it this way. But in Python 2, you actually don't have the parentheses. You actually do like print like that, which here will throw you a syntax error. And it sort of knows in the error message, it knows that the old version of Python, therefore they tell you, did you mean to do this? So if it took me like a good couple of months to like remember to put parentheses around these. So just for some background, that's like for me, like one of the biggest syntax changes from Python 2 to 3, but there are some others. I can't remember them right now though. All right. Okay, so we're just gonna run through some Python 101. Mainly, these are all things that are already built into Python. We're not gonna work with any libraries for today. So we're going to talk about really quickly the four main data types that we have. Four main types of collections, and we're going to talk with collections some definitions and keywords that you would use to describe these different collections that might come up in interviews. And then at the very end, we'll just go through a very quick logic flow problem. Okay, so to start, let's talk about our string and string methods. So as you know, a string is just, text, anything in quotation marks, and a string is, characterized by quotation marks. One very useful thing, right? I know for right now, it's not going to be very, very like groundbreaking, but a very useful built-in function that you can use in Python is the type method. Wrap anything within type and it'll tell you what kind of data type it is. For right now, it's very obvious as a string, but there will be other instances we'll see actually on Friday when you have very large data types, it's not immediately obvious what the data type is. So this is a string. Within string, there are a ton of string methods. This is just one example of a string method, but what I want to point you guys to is getting used to reading documentation. So W3 Schools, I like this for like beginner Python. W3 Schools has a list of all the built-in Python string methods. So these are all of the Python built-in string methods that exist. The one that I have as an example here is dot replace. You can sort of read, what I like about Python is it reads kind of similar to English. What I'm doing here on this string, I'm replacing all of the O's with X's, but only 2 times. So when I do that, you can see that the O's in welcome and to get replaced with X's, and then the O's for the rest of the string remain as O's. If we take a look at the specific documentation for replace, which is here, it sort of tells you how it works. So definition and usage, syntax. I usually like to look for something like syntax and maybe parameter values. So if you look at syntax, it says you have to do it on a string, use dot replace, old value, new value, count. So that's just a quick way. I think it's very important to get used to reading this kind of documentation. As you can see, there are a lot of string methods. I can tell you off the top of my head, I know no more than 5 of these. So what I do know though, is there is the functionality to do some of these actions, but I don't necessarily remember, okay, if I want to do like a dot strip, how exactly does dot strip work? To be honest, I think for dot strip, I always like flip flop like where the arguments go. But yeah, can't remember off the top of my head how to do that. But if I know how to read documentation, figuring out how to use it properly becomes a lot easier. So yeah, here I know that now it's string.strip, what characters am I stripping out? Very likely if you're doing something that you think is fairly simple to do, there is a built-in Python method for that. So if you need to do a task, I would say, if you don't know if there's an existing function to do it, Google if there's an existing function to do it. It will save you a lot of time versus just like, I don't know, iteratively like looping through and like doing it one by one. So getting used to reading documentation, super, super important. Okay. Any questions before I move on to other data types? I think strings is pretty one of the more basic ones. All right, so let's talk about numbers and math. So with numbers in Python, the main data types are integers and floats. And within cells, you can do math operations. I will tell you the first thing that I used Python for was to do math, just because, I don't know, I have a math background and just doing these math, I sort of use that as a calculator. So you can pretty much do whatever math things you want in any cell. Something that's pretty neat is that types, integers and floats can work together. Obviously, if you have like a decimal number and you have like an integer number, they probably need to work with each other, and that works. Something to just keep in mind is when you are using integers and floats together, the result is usually a float. So as you can see here, I'm adding 5.0, which is still 5, plus 6, the result is still a float. So if I take away this type, you can see it's 11.0. Some less common but potentially useful operations that you can use with numbers. The modulo the modulo operation, which is a percent sign, will give you the remainder after you divide something. So here, 8 modulo 3, basically like 8 divided by 3, that gives you a 2 with a remainder of 2. So therefore, your remainder is 2. This, I will say, is most commonly used to check for like even numbers. So usually if you want to check if something is even, any even number modulo 2 will always be 0. So if you want to just check if something is even, that's a quick way that you can do it in Python. And we'll actually have some examples of doing that on Friday. Another less common one, but could be important, is floor division. So floor division gives you the quotient. So basically, if you think about it, it's like division, but you round it down. So 16 modulo 3 will, if you think about 16 divided by 3, it will give you like 5 remainder of 1. The floor division will give you 5. This is something that will also potentially come in handy, especially when we come to visualization. There's one part in visualizations that this comes back with like subplots. If anyone has seen that in the pre-work, that's what that is. All right, so numbers I think are pretty straightforward. Again, if any questions, I like to be interrupted, so please just chime in, unmute yourself if you have any questions at any point, because I know I talk pretty fast as well. Okay, so Booleans and logic, this is when it can get a little bit confusing. Basically, if you want to combine multiple conditions together, you're going to use Booleans and logic. So here you have your true, false, your and, or, and your not. I would say this is a lot easier to think about when you have a specific situation to use this, just because it reads more like English. If you just have like the trues and falses without context, it's sometimes a little hard to think about, okay, what's going on here. So just really quickly to run through, there are trues and falses. These are your 2 Boolean values. Something can either be true, either be false. I think somewhere in the lessons, they talk about truthy and falsy. That's even more complicated. I will say for data science, truthy, falsy, a little bit less important. But we have, if something is true, if you have 2 things, true and true, if you have 2, not things, but let's say you have 2 conditions, and if you want to find the result, if both of them are true, true and true, you will use and it'll evaluate the true, true will also give you true. If you do true or false, this is when things change. True or false will still give you true, but true and false will give you false. I know I said like a lot of words in succession, but this is something that I think I don't want to spend too much time on this. I think this is something where the lessons are a good way to get familiar with this. So that's true, false, and or. The not is also useful. So so this is from something else. This is from below. So let's say true and false was false, right? But if we throw a not in front of it, we get true. So not sort of like works like a negative sign, flips the true false. And then not true is false. Something else that could be pretty cool, I think, let me just double check if this works. If you do true plus true, it comes out as 2. That's pretty neat to know that like true and falses are actually assigned numerical values, 0s and 1s. So you can actually kind of perform mathematical operations with trues and falses. Again, it depends on your function. If you're already working in Booleans, this might come in handy, but just know that true in the backend also evaluates to the number 1 and false also evaluates to the number 0. Cool. I know I'm going through this pretty fast. So if anyone has anything to like clarify, please let me know. Okay. So variables, you can assign anything to a variable. I will say when you're coming up with variable names, I know at the beginning it's hard to like think of variable names. I also sometimes think about like, what should I name this variable? To your best ability, try and name it something that's indicative of what it is. A bad example is here when I have 5 equal to 7. We do not want 5 equal to 7. We want 7 equal to 7. But instead, let me do 5 equal to 5 because this will help later. So anything can be assigned to a variable. Things to note with variables in Python, there are certain keywords. So for example, if you want to call the variable something like def, you know that def is used to define a function. So don't call a variable def. Whenever you see the word highlight green, that's just a good sign that you should not name your variable that. Some common ones that people sometimes use is like ID is actually a keyword. What else is a keyword? Like return. Return is a keyword. Don't do that. Also, don't name your variables true and false like that either. It will sometimes work, but if it clashes with anything else in your code, it will not. Other good practices to like not name your variable names, if you're using a method being like here, I'm using like dot split, right? Dot split is a string method. Try your best not to name your variable split because that will actually run into issues later. I think if I try this right now, this might break it. So let's try split. Let's just say that we're testing something. I wonder if this will work or not. Let's see, words is here. And then if I run this, oh, okay, this still works. But sometimes it'll say that you're trying to run a string on a string. So just be careful with naming your variables, things that are also the names of the methods. So yeah, I know that makes naming variables very, very complicated, a lot of constraints, but just try your best. Cool. So let's ignore this for now. Yeah, you can assign anything to a variable. Here, I'm just using the variable names, but it just does the same operation. 13.5 when I add 5 and 8.5. I'm running a string method on a variable that has a string assigned to it. And also variables can take Boolean values. Here, is it was equal to false, not is it is now true. All right, so those are our main Python data types. After data types, we're going to talk about collections. Going to take like a half a minute breather here. Anyone have any questions or just have everything like just sink in during this time?
I was just gonna say that I've seen if you absolutely really want to use like one of those words, adding an underscore at the end is something that I've seen done like on online where people will do that, and that doesn't seem to mess with the code too much.
Yeah, that's actually a really, really great thing that you brought up, Dimitri. Thank you for that. Yes, absolutely. If you want to really name, if let's say like the most indicative name for your variable is the word split, one common way to do it is to call it split with an underscore equal to whatever. That's a really good one. You might have also seen underscore used before at the start of a variable name. I would say this is more for like, these are more called, I forget the name. I think it's called something like hidden variables or like secret variables or something like that. These variables are just meant to just store information and not really meant to be referenced. So if you ever come across something like that, that's also pretty common. More common in object-oriented programming, which is a different style of programming that we'll talk a little bit about in phase 3. Just good to know. Thanks for being here. Yeah.
I have a question. So with when you said there's a numerical value associated with true and false, is false then always 0 and true always 1 because of because of how binary works?
That's right. Yeah, it's very similar to, because I don't know if it's exactly because of binary, but it's just like binary in
because
that
binary false is always passed in logic. Binary logic always has false is 0 and true is 1. So I'm assuming that's probably the same way it works in Python.
That's right. Yeah. So false plus true will give you 1. Let's see if we can do like a false. Is false equal to 0? Yeah, that's true. So yes, false evaluates to 0 always, and true always evaluates to 1. Yeah, this is a trick that sometimes you can use to save a couple lines of code. Cool. Anything else? All right, the next section when I'm talking about collections, this is like kind of the part that I want to like really highlight certain things that are going to be helpful when you're working across over the next couple of topics. Okay, so let's first talk about lists. I think lists are right now like the most user-friendly data type in my opinion. The main characteristics of lists to remember is that they are ordered and they're mutable. So what does it mean when something is ordered? As long as something is ordered, it means that you can index them. And so let's just take this list, and this is just a random list. You can put anything you want in a list. It doesn't have to be consistent, which is sometimes great, sometimes not so great. But you can put anything in a list. Here I have 0, 1, 2, 3, 4, 5. I put a string hello. I put a Boolean value true. These are all valid list elements. So because it is ordered, I can pull out elements of a list using indexing. So if you remember, indexing always begins with 0. So this just means I'm pulling the 4th element, because 0, 1, 2, 3, I'm pulling out the 4th element of my list. And any data type that allows you to do this, it is ordered. So just for a more like meaningful example, I guess, that's just to show how we can get the 6th element of hello. Anything that allows us to use square brackets with a number in it to get, like, you know, whichever order it is, that just means that that data type is ordered, and lists are ordered. The fact that it is mutable means that you can actually edit elements within a list. So as an example, to show that list is mutable, let's just say I want to edit the number 4 to become the word 4. That runs with no error. And if I output my list again, you can see that it's been updated to 4. That's just because lists are mutable. You can always edit elements within a list. With lists, there are also destructive and what's the opposite of destructive? I guess non-destructive methods. One most common thing that you're probably going to see and come across and use in your code is the append function. So the append function will basically add elements to the end of a list. And this kind of method is destructive. But what I mean by destructive is just that it actually edits the actual list. I'll show an example to contrast that right after this. But when I do mylist.append 8, it just adds 8 to the end of the list. The list has actually been changed. So here, 8 is still in the list. As an example of something that isn't destructive, and also to show a pretty neat way to use lists, you can actually add lists together. This is a non-destructive line of code. Here I'm taking my list and I'm just adding a small list with 9 and 10 together. And you can see that my list still doesn't change, but let me comment this out. Oh, by the way, helpful to know, control ? Automatically comments and uncomments a line of code. If you want to do multiple line, you just have to highlight them. And that's a really neat shortcut that I think is good to know. But yeah, if I sum any 2 lists together, it puts the elements of the list together into one long list. But something like this is non-destructive. This actually has not changed the list, because if I look at my list again, and actually, let's just run my list again. The 9 and 10 has not actually been added. The only way to actually add this 9 and 10 to the end of the list is if I reassign. If I do like my list equal my list plus 9 plus 10, then like that, you can see that we've added 9 and 10 to the end of the list. All right. Another method that I want to bring up that is different from append that some people kind of get confused with is append versus extend. So there's mylist.append 8 where I added 8 to the end of the list here. There's also mylist.extend 8, which is another destructive method, but let's take a look at what happens here. I think this should break. That's right. Okay. So mylist.extend 8, and let me just do, let me show you why this doesn't work. So when I ran this code, it said that, well, it broke on this first line here. And it says the int object is not iterable. The int object, meaning the integer that I'm feeding it in, which is 8, is not iterable. So, okay, that sort of tells us that within .extend, they want me to give it some sort of iterable object. So you cannot iterate over an integer, but you can iterate over a list. Let's try that. If I wrap some square brackets around, it becomes an iterable list. Even though there's only one element, you technically can iterate through it. When I run that, you can see that it's added 8 to the end. because I'm extending it by a list, maybe I can add 8, 9, and 10. And actually, let me just rerun this so it's cleaner. Okay, so now my list is back down to this. But now we can extend 8, 9, 10. Sweet. So when I do dot extend 8, 9, 10, it has added 8, 9, 10 to the end of the list. Very nice. So let's rerun this again, but let's try this differently. Instead of extend, we do append. And let's see what the result is. So remember, actually, let me just copy and paste this so we can have them to compare with each other. All right, let's look at append. All right, so that was the result for extend. This is the result for append. Very, very subtle difference, but what append has done is it's added this entire list as one element. So that's an important thing to remember, the difference between append and extend. Sometimes some people try to do like a dot append, and then you have to do another function to like unnest the lists, but dot extend exists, which is pretty neat. So that just to double check, if I look at my list now, my list looks like this. The last element is a mini list. And then you have to go through some extra work to like get those elements out into the main list. So if you're doing dot extend to start, that solves you from having to do these extra steps. All right. So extend versus append, very important difference to know. That will come in handy at some point. All right.
So question on extend. So extend versus append. So extend, essentially, you need to use an iterable within the parentheses, and append, you can use anything.
That's right.
Essentially. Okay.
Yeah.
All right.
Yeah, great clarification. Yeah, append will take whatever you put within the parentheses as a single element to add to the end of the list.
An extend has to be something that you can actually iterate through, and not just how would I call it, a integer or something that is a constant and isn't variable. Okay.
Exactly. Awesome. Okay, so let's just reset this. I know this is getting messier and messier, but this notebook I really think is good for just playing around with. So if you do download this notebook, it's a good opportunity to just like play around with all these different things. All right, so let's just reset my list. I know this is a lot here, but okay, my list is back to this original one. The neat thing about lists is they are iterable, as we saw with the example with extend and append. Because they're iterable, we can loop through it. So I'm just printing every element in my list. That works. Cool. Other things to note, and this will also come in handy at some point. List range length is also something that's pretty good to know of. So list range length, if we break it down, what is length? Length just tells you literally the length of my list. So length of my list, right now it's 8. Range is a method that is pretty neat because it just gives you, it turns a single number into a range up until that number. If I do this here, it gives me this range object, but if I coerce that into a list, you can see that it actually gives me 0 through 7. So it gives me these range of values. So sometimes you would prefer to do this. We'll see some specific examples in the coming topics, but this is a pretty common thing. Instead of iterating through the actual elements, sometimes you want to iterate through the position of the elements. That's where range length comes in handy. So we have list range length. This is redundant now, but if we take a look at this, for I in range length my list, and the range object, if you remember, even though range showed us this like 0 to 8 thing, range is actually iterable as well without having to coerce it into a list. So which is why this still works. So if I print I, you can see it prints 0, 1, 2, 3, 4, 5, 6, 7, which is, what belongs in range 0 through 8. But if I instead have it print my list index I, it prints the elements of my list. That's something that's just good to be aware of. If for any reason you need to keep track of the position of elements rather than the elements themselves, that's something that's good to just remember that you can do. Okay. This next dictionary section is the more important one of this study group. For those of you who have seen topic 3 is going to be working with a lot of big dictionary structures, JSON files, which are basically giant dictionaries. So this is going to be really helpful, but we're going to use a very small dictionary to just show, to just demonstrate the things that we're going to try and remember for topic 3. So dictionaries take on key value pairs. So the structure of dictionaries, there's always a key with a value, and these always come in pairs. You never have a key without a value, never have a value without a key. Something else about dictionaries is they are not ordered. So what that means is if I do try and get like the first item of the dictionary, of any dictionary, it's going to give me a key error because dictionaries are just not ordered. You cannot index through a dictionary. The only kind of loophole exception is if your keys are numbers, then sure, you can do that, but it's not exactly doing the same thing. Also very similar to lists, they are also mutable. You can also update things in a dictionary. So to start, we're going to use this really, really simple dictionary, my car dictionary here, brand of Ford, model Mustang, year 1964. Here I want to just share some methods that are going to make it easy to perform functions over dictionaries. So dictionary versus dictionaries dot items. So here we have our dictionary, which cool. This is a syntax that we should be kind of familiar with. Curly brackets, each key value pair separated by commas, keys and values related to each other through colons. So the one downside with dictionaries is because they're not ordered, iterating through them becomes a little difficult. So there is mydict.items. Let's just see what that looks like. So in mydict.items, you can see that the values are the same, but instead of having the curly brackets and the colons, it's actually a list of tuples, which if we want to edit a dictionary, if we want to, systematically change a dictionary in some way, becomes more helpful when it's in a list of tuples, because as we know, lists iterate very nicely. So let's just take a look at the types. The type of the dictionary is a dictionary. The type of the dictionary items actually has its own kind of type, dict items. I'm going to edit this once and just take a look at the first element. Oops, this is not what I meant to do. All right, we'll look at that later. But if we take a look at dictionary items, yeah, dictionary items is this list of tuples. And I'll show you why that's important. So in Python, you can sometimes coerce things into other data types. Here, as an example, earlier, for this range object, we could have coerced it into a list to get like the numbers 0 through 7. That's known as type coercion. If I try and coerce a dictionary into a list, something really interesting happens. So all I did here was just pass the dictionary variable into the list coercion, and what was returned was only the keys. So whenever we try and coerce a dictionary into a list, it only saves the keys. So that's something that's very important to remember. So some people, if you're trying to like loop through a dictionary, decide to put it into a list first, you're like, okay, I cannot find my values. So that's what happens there. Whenever you try and coerce a dictionary into a list, you only get your keys. So if I was trying to loop through my dictionary, so this again is just the dictionary variable, and I'm printing I, it only prints out my keys, which is not ideal. Like ideally, we want to keep all the data that we have. So this is where items comes back and comes in handy. So here what I'm doing is instead of looping through the dictionary itself, I loop through mydict.items. And so that's what saves the key value pairs. So the difference here is I just added dot items, and from that, I was able to have my key value pairs. Nice. Let me just like zoom in a little bit. I realize this could be a little small. Okay. So just to get a sense of what's really going on here, what is the type of each tuple? Well, it's a tuple. So each of these that are being printed is a tuple with the key as the first item and the value as the second element. So now we know that if we do dot items, it turns a dictionary into a list of tuples that you can use maybe more efficiently, depending on what it is that you want to do. All right, quick segue. We're going to talk about just creating new dictionaries. So really quickly, I'm going to show two ways of doing that. So first, I have two empty dictionaries. Often when you're working with functions and you want to like update data types or make changes to your data types, sometimes it helps to just create empty versions and then just re-add your edited elements in. So that's what we're going to do here. It's a very, very common thing to do for lists as well. So this is our first way of doing it. For I in myDict.items, we can assign to the new dictionary the key of I0 equal to the value of I1. What this means is, this is the syntax for adding a new key value pair to a dictionary. So to add new key value pair to dictionary, the syntax is dictionary variable key, and then, not colon, but equal to value. So that's essentially what I'm doing here. My goal here is to take the dictionary that I originally had, my dict, and just insert the same values into the new dictionary. So I'm doing here, I'm calling the new dictionary variable. In square brackets, I say that each I0, so each first element of the tuple is going to be the key, and then each second element of the tuple is going to be the corresponding value. And then we'll print new dict to see whether that updates. Done. So with that syntax, that's one way that you can update update your dictionary. Maybe you want to like change it. Maybe you want it to be like instead of just I1, maybe you want to do, I don't know, maybe you want to do something funny like string this, I don't know, plus updated, something like that. That works. So just to show that it's a new dictionary, there you go. If you have multiple keys, the latest key will overwrite the existing key. So for example, if I wanted to do this step again and just say that for new dict year, if I want to do like, I don't know, maybe it's 1965 instead, that runs. If I rerun, let's do this here. I rerun this, it overwrites to 1965. So just take a note of that. If you wanted to store something like color and your vehicle has multiple colors, each color will overwrite unless you decide to store it as like a list of values. So just an example, let's just say color, and let's just say this car is red. Cool. Car is red. If you want to add that the car is also black, black will overwrite unless you put it in a list to store both red and black. So that's okay. Cool. There's also the update, but this, every time I do it, it doesn't work and I forget why. Yeah, so we're not going to talk about that right now. Update is less used now because we have this syntax, but it's supposed to be exactly the same thing. That might be a Python 2 thing, I forget. Okay. The other thing I wanted to talk about is iterating over multiple, what's the word? When you have multiple variables in your iteration. So here it might look kind of complicated, but it's pretty much the same thing. And actually, let me do this separately in another place. So here we have my dict.items, right? And instead of just doing for I in my dict.items, which is what I did here, I'm doing k comma v in my dict.items. So let's just break down what this is doing. So this is actually a pretty neat thing with Python. It's known as unpacking. So let me just print kv real quick. Cool. So Python is really great because it does this thing called unpacking. When it notices that every element in my dict.items is a tuple, so it's pretty consistent. Each tuple is a length of 2. it can sort of figure out if I'm giving it two variables here, it sort of knows to unpack it in a way that, all right, the first one will always be K, the second one will always be V. That's something that's pretty neat with Python. So by doing this, it can make our loop even more, I don't know, maybe look even better. Because before here, we had to deal with like, okay, this is the first element of the tuple. This is the second element of the tuple. Whereas now we just have K and V are often used for like key and value if you're looping through a dictionary. So the pretty neat thing here is I can pretty much do the same thing for the second dictionary. New dict2, key of K equals the value V. And that does the exact same thing. So this unpacking thing is really, really neat. If you ever needed to like assign multiple variables, you can also use unpacking. This is X and this is Y. If you wanted to do like X and Y just in one line for whatever reason, you can do that. And X will be given, this is X, Y will be given, this is Y. So that's something that's pretty good to know because Python supports automatic unpacking. If you have like an inconsistent number though, let's just say like you have Z, there we go. It says too many values to unpack. So you have to really make sure that it's something consistent. Usually if you're doing like a dictionary.items, it already knows dictionaries do come in key value pairs anyway, so it's going to be consistently like two things to unpack. But yeah, just a pretty neat functionality of Python. Cool. Oh, also to show that the range length on .items also works the same way. 0, 1, 2. Okay, ooh, we're only at 5 minutes left. Okay, I think that was kind of the main thing I wanted to talk about. Just the functionality of .items and unpacking. This last part, we're going to talk about some other dictionary methods that are going to be useful. You can get keys and values separately if you'd like. So right now I just did .keys and .values. This got me my dictionary keys and values separately. The data types are keys and values respectively, as expected. And you can also loop through all of these things. So yeah, just good to know. If you ever just needed to get a list of keys, sometimes if you have like a gigantic dictionary with like maybe I don't know, 100 keys, or maybe your values are just really long, so you can't really see them in your cell, very useful to do a .keys to just quickly inspect your giant data type. Sweet. And yeah, you can also coerce them into list objects, although these are already on their own iterable. Okay, sweet. I think we're gonna finish just in time with our sets and tuples. So sets and tuples are two other data types that are quite similar to what we've already seen. So sets are like dictionaries, but not paired, and the values are unique. So a set is also like dictionaries with our curly brackets, but a set gets rid of your duplicate values. Very similar to how in a dictionary, we couldn't have multiple of the same key. In a set, you cannot have multiple of the same value. So if I define my set to be 1, 2, 3, 3, 4, my set will still evaluate out to be just 1, 2, 3, 4. If I have a list with, let's just do a test list of like 1, 2, 3, 3, 3, 3, 4, and I just want to find the unique values of test, a very easy way to do that is coerce a list into a set. So just by doing that, that's how I find the unique values. So sets are usually used to find just unique values of collections. The next thing I want to talk about is tuples. So tuples, as we saw, tuples were the data type in the round brackets. The main thing with tuples is that they are immutable. So all of these other data types that we talked about, these other collection types that we talked about, so lists, dictionaries, sets, these are all mutable. We can edit their values in place, but tuples are not. So if you take a look at a tuple, just call it 1, 2, 3. I just want to reassign this 2 to be a 4. The error, it says tuple object doesn't support item assignment because it is not mutable. So a couple things are going on in this one line of code. We can index a tuple because it is ordered, but we also cannot edit their values because they are immutable. So tuples and sets are less commonly used to store data. But yeah, they are used here and there. Okay. Control flows we'll talk about more on Friday, because Friday we're going to deal with giant dictionaries, and in that time we'll talk about control flows as well. But cool. I know that a lot of this stuff seems kind of basic, but I feel like it's just worth practicing, and especially with like the dictionary.items, especially when you see like what we're doing on Friday, it's going to come in handy. So let me know if y'all have any questions. Does anyone have any questions at this moment right now? Cool. We breezed through a lot of Python in like this 1 hour. I think in like a college course, people would take like 2 weeks to go through this stuff. So feel proud of yourselves. Just know that this is a very, very fast-paced course. One more announcement. Not everyone has booked their one-on-ones with me yet. So if you haven't yet, don't forget to do that. Schedule your one-on-one with the one-on-one link. And yeah, if there's nothing else, I will see you all tomorrow back here at the same time. We're going to be talking about GitHub, so there won't be a notebook for tomorrow, but I'll send out like a list of things that we'll be going through right before our study group. Any final questions before we close out? All right, well, in that case, have a good rest of your day, everybody, and I will talk to you all tomorrow. Don't forget to leave your stand-ups. Bye, everybody.
Bye.